we have to define one more term. That's a biconditional statement. A biconditional statement is a combination of a conditional statement and its converse. And we can state it a special way. So if a conditional statement and its converse are put together, we say P, the first statement, if and only if Q. Let me give you an example. Here's a conditional statement and its converse. If it is a half day of school, then I will get Chinese food for lunch. If I get Chinese food for lunch, then it is a half day of school. Now, you could imagine how you might find a counterexample of this. You might see if you can find me with Chinese food for lunch on a day that is not a half day of school. So this second statement, the converse is unlikely to be true. The original statement might be true. Maybe every single half day at school I walk over to the Chinese restaurant and get Chinese food for lunch. Okay? Now, I could state this, if I put these two together so that both of them have to be true, I could state them a different way. I could state my hypothesis, okay, it is a half day of school. Then the phrase if and only if. Notice we moved the if from before the statement to the middle of the statement. And basically what that if and only if statement is doing is it's serving as an equal sign in the middle of the statement. Okay? It is a half day of school if and only if I get Chinese food for lunch. If this statement is only true if both the original statement and the converse of the original statement are true. Let's take a look at another more mathematical example of this. If x squared is less than or equal to 4, then x is less than or equal to 2. Let's take a moment and evaluate the truth of that statement. If x squared is less than or equal to 4, okay, so that seems to make sense. If x squared, that means that x is going to be less than or equal to 2. I can't think of any counterexamples to that. Even if x is negative, let's see, if x squared is less than or equal to 4, x could be negative 2, but x would still be less than or equal to 2. So this seems like a true statement to me. Now let's look at the converse. If x is less than or equal to 2, then x squared is less than or equal to 4. What if I go all the way down as far as negative 3 or negative 4? If x is negative 4, then x squared is going to be 16. And it's not less than or equal to 4 anymore, but x was less than 2 if it was negative 4. So therefore, the converse is not true. Here's the biconditional statement of this. X is less than or equal to 2 if and hold on a second. I notice I have this switched around. It needs to, and this is instructive, so I'm going to keep this in the video, but it needs to look like the original statement. Okay, so it needs to look in the same style as the original statement, not the converse. It shouldn't matter, actually, but just to be proper, it should be styled like the original. X squared is less than or equal to 4 if and only if x is less than or equal to 2. This statement puts the original statement together with its converse. However, because I know the converse is false, this is a false biconditional statement. Okay? Now, let's take a look at how we could figure this out with truth tables. What is my hypothesis? In this statement, my hypothesis is x squared is less than or equal to 4. And I'm just going to fill up my hypothesis column as I always do. What is the conclusion? The conclusion is x is less than or equal to 2. And I'm just going to fill in my conclusion column the same as always. True, false, true, false. So the hypothesis column is true, true, false, false. And then the conclusion column is true, false, true, false. Now I'm going to add on a statement column. This is the entire conditional statement. If x squared is less than or equal to 4, then x is less than or equal to 2. This is also going to have the same value as it always does. True if both my hypothesis and conclusion are true. False if I have a counterexample, the hypothesis is true and the conclusion is false. And true if I can't prove either way because I can't think of a true hypothesis. Okay? Next, let's add on to this the converse. Now, it helps when you're making these truth tables to be able to think through what the converse means. What does this statement mean? Well, converse means we're switching around the conclusion and hypothesis, right? So all I'm doing to figure out what values go here is I'm treating the conclusion as my hypothesis and the hypothesis as my conclusion. I'm treating the conclusion as my hypothesis and the hypothesis as my conclusion. So if my conclusion is true, that actually now becomes my hypothesis. If both my hypothesis and conclusion are true, the converse is true. Now look at this. The conclusion is false, but remember, that's my new hypothesis. If my hypothesis is false, I can't make a determination. So that means that my truth value has to be true for this one and for the last one. It doesn't matter if it's false. If this is the hypothesis now, if the hypothesis is false, that means that my statement, the truth table value is true because I can't disprove it. And then lastly, if I have a true conclusion, or which is now my hypothesis, right? A true hypothesis with a false conclusion is the counterexample. So the counterexample line actually moves down a line for the converse of a statement because I'm switching around my hypothesis and conclusion. So to prove the converse is false, what I need to do is find a true conclusion to my original statement, but a false hypothesis for my original statement, okay? And then lastly, the biconditional. Now, keep in mind, a biconditional is only true if both the statement and its converse are true. So, the biconditional is true only if we have a true hypothesis and conclusion or a false hypothesis and a false conclusion. But if I find a false hypothesis and a true conclusion, that's enough to prove my biconditional statement false. Okay? Now, you're getting lost in this, probably, because if this is the first time you're seeing this, you're going to be swimming a little bit at this point. I'm going to tell you this, just remember, biconditional statements, true, false, false, true. Converse, true, true, false, true. If you just need to memorize the pattern of trues and falses, you can do that, and that is a valid way of moving forward with this. These are not just for conditional statements, by the way. These work for compound statements as well, ones that combine two statements using and or. We've seen these before in algebra. So a conjunction is a compound statement that uses and. A disjunction is a compound statement that uses or. And notice that the truth table for conjunctions and disjunctions starts off exactly the same as the truth tables for hypothesis and conclusion conditional statements, okay? Because I can only have 4 different combinations of truth, false. True, 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 false, false, true, false, false. All right, now, a conjunction statement is it's not an if-then statement. It's just 2 statements that are either true or false. It is a half day of school. I will get Chinese food for lunch. Okay, it's just like the statements that are embedded in conditional statements. And if I say it is a half day of school and I get Chinese food for lunch, that's only true if both of those things actually happen. If one of those things doesn't happen, if it's not really a half day of school, then the conjunction is false because both of those things didn't happen together. Or if it's a half day of school and I get pizza instead of Chinese food, that's also a false statement. And then obviously if both of them are false, it's not a half day of school and I don't get pizza for lunch. Now, because I'm looking at the truth of each statement instead of looking at it as a conditional statement, one thing dependent on the other, now if either of these are false or if both of them are false, my conjunction is false. Or a disjunction statement, as long as one of them is true, the disjunction is true. It is a half day of school or I'm getting Chinese food for lunch. If I get Chinese food for lunch, that would be this and this, then my disjunction is true. If it's a half day of school, even if I don't get Chinese food for lunch, the disjunction is true because it only needs to be one of the 2 things. It's an or statement. And then if it is not a half day of school and I don't get Chinese food for lunch, that is a false disjunction. So because my statement was it is a half day of school And or I get Chinese food for lunch. And if I don't do either, that's false. All right, we're going to see how these actually work in practice problems next. Again, you're probably swimming a little bit. Stick with me. This is something that takes time, but you will get it.